Okay, so we're going to be talking about the Pythagorean theorem. And I know that you visited this in probably ninth grade, if I had, and I'm sorry, eighth grade, if I had to guess. So the Pythagorean theorem is probably one of the most, I don't know, famous theorems because it's so easy to remember and it makes so much sense. And it's been proven over and over again by multiple mathematicians in different ways over the years. So we're going to learn how to we're going to prove the Pythagorean theorem. We don't really need to do that, but there is a video on that if you're interested. We're going to use the Pythagorean theorem. We're going to learn how to do the converse of that. Converse means how do we prove that a triangle is a triangle or what type of triangle. And then believe it or not, we're going to use the Pythagorean theorem. This is kind of an add-on to what you probably already know. We're going to actually use it to classify triangles. So what do I mean by classify? I'm talking about acute, obtuse, or right. So we're going to actually use this to be able to classify the triangles. So again, one of the most famous theorems in mathematics is the Pythagorean theorem. Okay, it is named for a mathematician named Pythagoras. He's Greek, and it describes the relationship between the side lengths of a right triangle. So how do these sides relate to each other is what you're actually looking for. So you have your leg and your hypotenuse. And when you have the two legs right here, okay, add those together, square them, and that is equal to the hypotenuse squared. So we'll call this one A and this one B, and it doesn't matter which one is which because these are interchangeable. Obviously, if you add 1 plus 1, it's the same as 1 plus 1, so it doesn't matter. So you get A squared plus B squared is C squared. Now, there are something called, this is a new vocab word, called the Pythagorean Triple. Now, the Pythagorean Triple is just basically a perfect right triangle. Think about it that way. Because the Pythagorean Triple has 3 positive integers for A, B, and C. So you're talking about numbers like 1, 2, 3, 4, 5. Notice there are no decimals. So no decimals. And obviously no fractions because fractions can be made into decimals. So no decimals, no fractions. If you have perfect numbers here, in my mind, perfect numbers, integers, then you have a Pythagorean triple, but it has to be true for all 3 of them. So some of the most common, and these are only a handful of them, there are more. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And then not only are these Pythagorean triples, but their multiples are Pythagorean triples. So like if I multiply all of these by 2, if I multiply all of these by 3, and that's true for all of these. So all of these plus their multiples are Pythagorean triples. So let's actually try it. So we're setting this up. Adjust the paper so you can see it, hopefully. Okay, find the value of x and tell whether the side lengths form a Pythagorean triple. Well, these are my legs right here and here. So those are what are equal to each other, or added together actually, and equal to the hypotenuse. So when I add these together, I get 25 and 144. And 25 and 144, I believe, are 169 plus 144. Yep, 169. So last step here, when you're trying to find x, make sure you take the square root. Oops, sorry, finger stuck to that. So that's 13. So yes, this is a triple. So yes, 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 yes. all whole numbers, okay? We're all integers, and we're not looking at any fractions here. All right, let's take a look at this one. This one is 7 squared. Here's my legs. Identify your legs. They always make up that right angle. 7 squared plus x squared is equal to 14 squared. So x squared is actually equal to 14 squared minus 7 squared. So 14 squared minus 7 squared is 147. Double checking that. Yep, 147. And the square root of 147, that's your last step. You are looking at approximately 12.1. So this is not a Pythagorean triple. Okay? All right. By the way, you can always, if I'm going too fast, please pause the video, go backwards, right? Because this is about you learning. So make sure you go back and you rewatch it, and maybe something will click with you the second time or the third time. So the skyscrapers shown are connected by a skywalk with support beams. Use the Pythagorean theorem to approximate the length of each support beam. So here's your support beams that you want to solve for. Here's your leg. And you can use either one of these right triangles. There's 2 of them here. You can use this one or this one. Doesn't matter. So I have 47.57 squared plus 23.26 squared equals x squared. So I get x squared equals 2803.9325. Last step, take that square root. And you get x is approximately 52.95 meters. And that's how long this support beam needs to be right here on both sides, 52.95. 52.95, 52.95. Okay, the flagpole shown, whoops, I have this resting on the computer. The flagpole shown is supported by 2 wires. Use Pythagorean theorem to approximate the length of each wire. Again, these are my legs right here. And it's telling me my one leg is 15. Going from here to here, this is 15.1. They just didn't include it in the picture because it was too big to put in. So 8.5 squared plus 15.1 squared equals x squared. Again, I'm looking for the length of the support wire right here in the hypotenuse. So you are going to get x squared equals 300.26. So x is going to be approximately 17.33 feet once you take the square root. Okay, hopefully we're good on this. We don't have any questions. Moving on. So again, find the value of x and tell whether the side lengths form a triple. Well, you got your legs right here. Identify those first. It's a lot easier because then you know that's what gets added together in this. So 4 squared plus 6 squared equals x squared. So you get 52 equals x squared. Take your square root. And x is approximately 7.21. Now, guys, the reason I say approximately is because it's a decimal that goes a lot longer than that. I'm just rounding the decimal. So every time I use approximately, it's because I'm not getting an exact number. I'm getting a long decimal. Okay, so a very small fraction. All right. So the answer here is no, because I'm getting a decimal. Okay, this one. And I could just spill the beans for you right away on this one, because this is probably one of your most common triples, but we'll do the math on it. 5 squared. So you have x squared equals 5 squared minus 3 squared. If you're not sure what I'm doing there, I'm taking this and moving it to the other side by subtracting it. So x squared equals 16 and x equals 4, because I would take the square root of this. And yes, that is actually one of the most common triples, 3, 4, 5. Okay, that's the front page. Only a couple more to do on the back for practice, continued practice. But we're actually going to talk about the converse. Okay, how do you tell what type of triangle you have? And if it's a right triangle? Well, if a squared plus b squared is equal to c squared, it's a right triangle, period. It's a right triangle. But if it's not, then it is an acute triangle or an obtuse triangle. And so that's what you need to discover, what kind of triangle you're dealing with here. So start off with this one, and you get your legs. By the way, it didn't mark this right angle. It didn't mark it specifically because we don't know if it's a right triangle. Okay, the reason I know these are my legs is because the square root of 113 is bigger than 8 and 7. So square root 113 is 10.63. So I know it's the longest side. So I'm going to assume that's my hypotenuse. Okay, because it's the longest side. So I have 8 squared plus 7 squared equals the square root of 113 squared. But when you square a square root, that is just 113. Just let me know that. And when you do these, you get 113. They are equal. So this is a right triangle, because that's what it asked me for. Is this a right triangle? Yes, it is. Okay. Okie dokie. On this next one, again, 4 times the square root of 95 is more than 36 and more than 15. I know that for a fact, so I am going to make that my longest side and make these my legs. So you have 15 squared plus 36 squared, and that is going to equal 4 root 95 squared. Okay, so this is actually 1521, and this is, let me do the math real quick, 4 root 95 squared, 380. So you can see this isn't a right triangle. Because 15, because that's what that was. Okay. And then the other part here, 36 squared plus 15 squared. Oops, I forgot my squared. 1521. So not a right triangle. But then you're asking yourself, well, what kind of triangle is it? So we're going to get into that. Let's talk about that for a second. Now, originally when I did this, and I'm wondering if I made a mistake, because originally when I did this, I got that. It's still not a right triangle, but it was really, really close. So I don't know. We'll see. Okay, because you know I can make mistakes too. You've seen me do it. It's okay to make mistakes. Mistakes are your friends.